Welcome class 10. Today we are going to discuss thermal capacity. So let's say there are two different bodies, body A and body B. We have already learned that in order to raise the temperature of two different bodies of the same mass, there will be different amount of heat energy required. So the heat capacity of a body is the amount of heat energy required to raise its temperature by 1 degree Celsius. So the difference that is there in order to raise the temperature is because of heat capacity, because each and every substance has their own or different heat capacity. So heat capacity is represented by C dash, which is equal to the amount of heat energy supplied divided by rise in temperature. So amount of heat energy supplied by rise in temperature is the heat capacity C dash. So if a body A is supplied by heat energy Q, okay, the quantity of heat energy is Q, in order to raise the temperature from T1 to T2, then the difference in the temperature will be equal to T2 minus T1. So let's say the difference in the temperature is 1 degree Celsius. That is, in order to raise the temperature of this body from a certain temperature by 1 degree Celsius or 1 Kelvin. Okay, so that is the difference of temperature, that will be T2 minus T1. So the heat capacity can be represented as Q by T2 minus T1, where T2 minus T1 can be represented as del T. Del T means the difference in temperature. Units of heat capacity. SI unit is Joule per Kelvin, written as J per Kelvin per K, or also we can write as Joule per degree, written as J, okay, Joule J per degree Celsius. Okay. Other units that are used are calorie per Kelvin or calorie per degree Celsius. Also we can use kilocalorie per Kelvin or kilocalorie per degree Celsius. Here you should remember that 1 calorie is equal to 4.2 joule and 1 kilocalorie is equal to 1000 calories. Specific heat capacity. Let's say we have a body of 1 kg. Let's say we have a body of 1 kg and heat is applied to raise the temperature from T1 to T2. And let's say the difference of this temperature T2 and T1 is 1 degree Celsius. That means the temperature is rising per degree Celsius. Okay. So in order to raise the temperature of 1 kg mass of this substance through 1 degree Celsius, the amount of heat required will be called as the specific heat capacity. So the specific heat capacity of a substance is the amount of heat energy required to raise the temperature of unit mass of that substance through 1 degree Celsius or 1 Kelvin. Specific heat capacity is represented by small c, which is equal to the amount of heat energy supplied by mass into rise in temperature. The specific heat capacity, therefore, of a substance is the heat capacity per unit mass of a body of that substance. Okay, because the heat capacity, we have already said, that is the amount of energy, heat energy required to raise the temperature by 1 degree Celsius. So over here, only in case of specific heat capacity, the mass is required. So how much mass is there? It has to be a unit mass. So this unit mass per unit mass means it is the heat capacity only for per unit mass of a body, then it becomes the specific heat capacity. So C, that is the specific heat capacity, is equal to heat capacity of a body C dash by mass of the body. And we have already learned that the heat capacity is equal to Q by del T. So we can replace this C dash out here with this value Q by del T. So over here you will get C is equal to, the value of C dash is Q by del T by M. So it will be Q by M into del T. So when you cross multiply these denominator with the numerator C out here, we will get Q is equal to M into C into del T. So Q is equal to M into C into del T is the important formula which shows the relation between the heat energy, which is equal to the mass into specific heat into the change in temperature. So with this formula we come to know that the quantity of heat energy absorbed to increase the temperature of body depends on, number one, it depends on the mass. See over here, more the mass, more will be the heat energy required. So it depends on the mass. Next, it depends on the increase in temperature of the body. So how much is the increase of temperature? So this quantity of heat energy absorbed will depend on how much increase in temperature takes place. And also it depends on C, that is the specific heat of the body. Specific heat means it is related with the material of the body. What kind of body what kind of material the body has. Okay, if it is a good conductor of heat or if it is a bad conductor of heat. Okay, on these factors, this C, that is the specific heat capacity, will depend on the material of the body. Unit of specific heat capacity. SI unit of specific heat capacity is joule per kg per Kelvin, and also it is joule per kg per degree Celsius. The other units are calorie per gram per Kelvin or calorie per gram per degree Celsius, or also you can use kilocalorie per kg per Kelvin. Relationship between the heat capacity and the specific heat capacity. The specific heat capacity is equal to heat capacity by mass. Here the mass is related with specific heat capacity. Okay, so when you interchange this value, bringing the denominator with the numerator in the left hand side, this M comes over here, then we'll get C dash is equal to M into C, that is the heat capacity is equal to mass into the specific heat capacity. So this is the relation between the heat capacity and the specific heat capacity.